Okay, hello, my name is Alexander Mann. I work for TGW Logistics Group, and today I want to give some insights and share some of our experiences that we had with building data-driven applications. We are also, like my predecessor said, in an exploration area. We are doing first projects with customers, first MVPs, to prove that this actually has a benefit. Some words on TGW. TGW plans, designs, builds and maintains automated warehouse solutions all over the world. We do that basically in intralogistics, so everything that is inside the four walls of a warehouse building. We have customers like Amazon, Zalando, also big customers in the apparel business, in the grocery business. Everybody that has a need basically for supply chain processes. So there are a lot of those. Some words on me. I have an academic background of mechatronics at the Johannes Kepler University, and I've been working for TGW for almost 20 years. Next week it will be 20 years that I work for TGW in various software positions. And roughly 3 years ago, I got the chance to join and create a group of people inside of TGW that we call the Digital Core. We always say an alliance of the willing. So people that are interested in driving stuff forward, thinking out of the box, finding new ideas. I don't know if they're not as radical as we heard before, but I think they're radical for an automation company. So some brief words on how we are doing this. So we have what we call a digital startup. So this is a group of people, they go to customers, they do workshops to analyze pain points in their supply chain process, to identify what's missing in our product landscape. And they do MVPs with the customers, and so we can turn, let's say, a rough idea into a concrete product concept. We have also the data science footsies inside. So the cognitive system teams, they focus on robotics, computer vision, AI to enhance the mechatronic equipment with new functionality, to enhance our software solution with AI. Then there's a bunch of people dealing with a digital twin of our entire site or our mechatronic equipment to be able to go back to the past, replay scenarios from the past, look at the current situation, go to the future, predict things in the warehouse. And last but not least, the team that I can lead, call it the connected warehouse. So our purpose, our goal is to implement a cloud-based platform to collect all the data from our worldwide sites and build data-driven applications so that we can give customer value to the people. Yeah, today's warehouses, probably the few of you have seen how warehouses look from the inside. They have turned really complex. So they have a lot of mechatronic equipments like mini-load cranes that operate in the rack, like shuttle solutions that drive in the racks and fetch stuff simultaneously. We have workstations that are manually operated and workstations that are fully autonomous with picking robots. There are kilometers of interconnecting conveyor belts and conveyor systems, hanging bag systems, and also autonomous mobile robots that cover distances that you cannot fix with fixed installations. So that is a complex system, and on top of that we have control software that manages all the operations of the equipment, and we have a lot of software for warehouse management, for material flow, to control all the transport processes, the logistic processes inside the system. So and this is actually the control room. Yeah? So from Coop, so some people from Switzerland are here, so they are familiar with this company. And it's really hard. Look at all those screens that people have to manage this system. And we have the vision that we want to manage warehouses like this in the future with a single tablet, that you can drill into stuff, that you can get information, notification when things go wrong, and the basis for this is data. We came up with a data concept. So the first thing is we need to collect the data from all those various data sources in the warehouse. There are so many things. There are control systems. There are energy measurement devices. There are all kinds of sensors. You have all kinds of protocols, Modbus, TCP, OPC, UA, all those things. And you need to acquire this data, and the key is to bring this data into one generic format that you can compare the data, that you can put it together, move it to a central data store, encrypt it securely. We heard the topic here that you can be on your data. Enrich the data with topology information, because you need to bring the data into the language of the warehouse people. So you need to link it with this. And of course, providing the data securely. Just a few words on how we built this. So we have all those machines in the field with a lot of devices and a lot of different data sources. And we built IPCs into the control cabinets. So on this, we have software that can collect all this information. And we enrich this information with data from the warehouse management system and send all of this up to the connected data hub. That's the name for our data platform in the cloud. And if you go to customers and you say, I want to have this data, the question is, what do I get for that? And so we came up with concepts of introducing digital assistants to the customer that help him optimize, run this warehouse. I will fast jump over this. So the building blocks for a system like this, probably you all know them. You need a good data IoT chain. You need different kind of databases. You need a fast time series database. You need a database for all the binary information. You need an API to access this data. And there are tons of different ways to do this. We decided for a mix of open source components, software as a service components, platform as a service component to link all of this together. Let's talk about applications. This is one of them. We call this energy monitoring. So we have energy measurement devices on all the machines. We collect all the blind energy, the active energy, the currents. And based on that, we can give a very simple thing, a report on the energy consumption of the site to the customer, the ability to compare with yesterday, with last week, with last year. But the real power comes when you combine this with the material flow volume, with the data from the material flow controller, because suddenly you can predict energy consumption based on volume. And if you know the volume of the next day, you can tell the customer what next day's energy consumption is, and they can buy energy data in the bulk, much cheaper. So that's one application. Another one is our digital twin of, I would say, the most complex device we have, our Pick Center Revolution. So it's an automating picking robot. It has a lot of different components that play together and work together. And we fetch all the information, fetch all the data, and display this all in just one user interface. Right? So you have the live web streams, you have a live image of the machine, so you can do data analysis, error analysis, right in front of the machine. And what you can see down here is this bar, this timeline. With having all this data and storing this data, you can go back to the past and review what happened in the past. So there were some errors, obviously here there was a lot of errors. So you just jump back, you see what happened, you see what the data was at that time. So that is very good for the customer. We have the classic topic of condition monitoring, looking at the device condition, computing the time to live, computing the date until the next maintenance is ready. Of course, picking is an important thing in this. So what are good items for picking? What are bad items for picking? Where do I have a lot of errors? Where do I have less errors? What items are robo-picked? And of course, the performance of the system and how does it link with problems of the robot? Or do I have something else in my system? And last but not least, on a high level, an overview of the whole system. So what's going wrong in my system? And that's what I said before. I want to have this tablet that tells me everything is fine, and if not, these are the problems, and I can drill down into the very deep of the problem and find the root cause and solve it. So data is the key to allow us to build those applications. Thank you.
Awesome.